All right, so number 9. So this is 10.3, right? Number 9, right? And we are asked to test this null hypothesis that some average is 105 versus the null hypothesis that the average is just not 105. Okay? And what we do is we take a simple random sample of size 35, right? And again, let me just ask you all these details as we kind of go through here. Why is this sample size important? Why is it important that n happens to be 35? And this kind of, yeah, because it goes to actually to part A, right? Part A on this problem says, does the population have to be normally distributed to use these methods? Right? And the answer is no, right? Because if our population, if you recall, is already normal, then I can take any size sample and those samples will be normal. But if the population is not normal, then I need to take pretty big samples to make sure that the samples are normal, right? And we came about in class to use this number n equals 30 or more. Right? So since we have 35 observations in our sample, I don't care if the population is normal or not normal. All I know is that the sampling distribution for all these samples is going to be normal. So I can still use these methods. All right, so that's kind of part A. All right, so for part B, it says someone went through the sample, got an average from the sample of 101.9, standard deviation from the sample of a 5.9, right? And we want to compute the test statistic, right? So, Adrian, this was yours, right? Because I can't see faces. I have this whiteboard pulled up. Okay, so let me pick on you then. How do you calculate this test statistic T naught? Uh, you bet. Yeah. So for this one, let's see, X bar is 101.9, mu is 105, S is 5.9, and the standard deviation, or the size of the sample, is 35. Okay. And what did you get when you calculated that number? All right, let's see. Let's see. Yeah, I was trying to find my work to see if I'd gotten the same thing, but I don't see it here. Oh, okay. All right. So that's fine. So let's see. So there's the t statistic, and we want to figure out, let's see, well, for part C, it says to draw the t distribution. So remember, the t distribution looks a lot like the normal distribution, only it's a little bit fatter on the curves on the end since it's a little more variable than the normal distribution. This is a two-tailed test, right? So we got one t-score of negative 3.108. Right? For the t distribution, 0 is always the high point. So what we want to do for a two-tailed test is find this probability and then find the equivalent probability over on this side, right? Which, since it's symmetric, that's a t-score of positive 3.108. Right? Now, the way the charts are set up in the book is when we look up these t-scores, we actually get the area to the right of that t-score. So what I can do is I can look up this number in my charts to get this p-value here, and then multiply it by 2 to get the total you get when you add those two together. Okay. All right, so that's the plan, Adrian. Does that make sense? Okay, so let's look at the charts then. So let me. All right, so here is our t distribution. Right now, in this case, since we have a sample of size 35, how many degrees of freedom do we have? You betcha. Okay, so what we'll do is we'll go along this row with 34 degrees of freedom, and we will go along until we see that t statistic. What was it, 3.108? Where if you go all the way down through here, it looks like it's 3.108 is between these two numbers right there. Okay, and if you go along to the top, that tells me what my p-value lies between. So based on this data, the p-value is between 0.001 and p and then 0.0025. All right, so do you see where those numbers come from? Yeah, we're not quite done yet. So let's go back to our picture, right? So this p-value is between 0.001 and 0.0025. Multiply it by 2, right? So 0.001 gives me 0.002, and then 2 times 0.00, I'm sorry, is it 0.0025? So that gives me 0.005. So when I add both of those together, my p-value is between 0.002 and 0.005. Yeah. Now, again, that's for a two-tailed test. That's the only time you have to add them together is if you have that two-tailed test, right? So they ask us to test this at the alpha level of 0.01. So based on this p-value and that alpha level, do you accept or do you reject the null hypothesis? You betcha, because that p-value is smaller than alpha, right? So here we will reject the null hypothesis. Okay, and let's see. Yeah, I guess that's it, right? All right, so does that make more sense for you, Adrian? Okay, awesome. All right, anybody else have anything from 10.3 before we look at some of the other review problems? Hear this stuff. All right, so you see where that one came from, Adrian? All right. How about this one? Let's do a different one on this same problem. What if we looked at part D? Okay. So for part D on this one, what we want to do is find the critical T value that corresponds to a 90% confidence interval with 20 degrees of freedom. Right? So if I have a 90% confidence interval, remember that means we have 90% here in the middle. So how much goes into each tail? Sure. Right? 5%, which is the same thing as 0.05. So what I want to do is I want to get this t-score, and in this particular example, I want to have 20 degrees of freedom. All right, so again, let's go back to our chart, and let me erase this stuff here. So for this one, what probability am I looking up? All right. Well, I want to have 0.05 in the tail. Right. So what we'll do is look at this particular column right here. And for this one, I have 20 degrees of freedom. So it's going along this particular row. So they meet up right there, which is the z-score of 1.725. So we can go back to this t-score and make that 1.725. And if we needed this lower one, that's just, since it's symmetric, that's negative 1.725. Okay. All right, so that's how you can start looking up those z-scores. I'm sorry, those t-scores, my bad. Okay. All right, is that more clear for you, Adrian? Awesome. Anybody else have any questions on that one we were doing from 9.2? All right. All right. So in chapter 9, if you remember what we're trying to do in chapter 9 is we've got a population, right? And we've got some type of a question that we are asking the population. Right? Again, the only way we could ever actually get that number is to do a census. Right? So we could either, I don't know, let's say we talk to all of the Transylvania students where the size of this population, let's say, is 1,100 students. Okay? Again, we don't want to talk to everybody, so what we'll do is we'll just talk to a small sample or a big sample, depending on how much money we got, right, to see what the sample says. And then we will just extrapolate that to the population, right? So let's say I ask the question where, let's say 70% of the students would say yes to something, which would equate to 770 out of the 1,100 would say yes to it. Okay? So I could ask this question as either a proportion type of a question, saying what proportion says yes, or I could say what count, what number, what average says yes. Right? So we are in chapter 9. we are trying to estimate the population's parameter. Right? That's what the actual values from the population are, right? Those are called parameters. Right? So what we're doing is we're taking a statistic from the sample, right? So maybe I will get p hat, which is the proportion from the sample, or maybe I'll use x bar, which is the average or the count of the sample. Okay? And depending on which one we are using, we'll set up a confidence interval to try to capture the value of that parameter. Okay? Now these numbers here, x bar and p hat, remember those are called estimates, or I think the fancier term was called a point estimate for either mu or p, depending on which one we're trying to estimate at the time. Okay? So that's what we're doing in chapter 9, right? We're trying to figure out what the value is from the population, trying to, find that parameter, and we're going to use a sample to estimate it for us. Now, the odds are the sample that we pull out isn't going to hit it perfectly right on the head, right? So what we do is we make a confidence interval, and we're hoping that somewhere in this interval, that value of the parameter falls inside there, right? And sometimes we'll capture it, sometimes we won't, because we could pull out a really bad sample of maybe all the high scores to where x bar may be way out here when it should be down in here someplace, right? Or maybe a bunch of low scores and we'll get the other end. Right? So how do we calculate these particular confidence intervals? Well, again, it depends on if we're talking about proportions or if we're talking about averages, right? So let's do a confidence interval for proportions. Right. So this is section 9.1 stuff. Okay. So if you have your book and you want to flip over to it, the formula that we're using is found on page 397. Right. It is p hat, that number that comes from the sample, plus or minus the appropriate z-score times the square root of the standard deviation of my samples, which is p hat times 1 minus p hat all over n. Right. If I want to find a confidence interval for the means or for the averages, right? So in other words, section 9.2 stuff, right? Then those confidence intervals are found on some page 410, and that is x bar plus or minus the appropriate t-score times the standard deviation over the square root of n. Okay. So these are the formulas that you're going to have to know. Right? And you have to be able to read through the problem to see which type of a setting you're in. Right? If they're talking about proportions, you use that setting. If they're talking about averages, you use that setting. Right? And we'll have to use our charts to either look up these scores or know them. Like for instance, for a 95% confidence interval for the proportions, right? That z-score was what, 1.96. I think the 90% confidence interval for the z-scores was 1.645 and so on. Right? And for these t-scores down here, for the 95% and 90%, didn't ask you to know those because you'll have those charts there where you can just look them up and get those values. Okay. Let's see, Maggie, was that you that asked that question? Okay. Did I ramble on long enough, or was there something else you wanted me to mention? Uh-huh. No, because the way they did that is they use software to actually get the exact number for it. But if we're using the charts, we're just going to have to get that range it's between, kind of like we were doing in the homework and the example we did before. Chapter 8 talks about sampling distributions. Right? And for sampling distributions, remember, a distribution tells you a couple of things. It tells you what values occur, right? And it tells you how often they occur. All right. So for a sampling distribution, what that tells me is what values the sample can take on and how often each of those samples occurs. Okay. So what we've got is some type of a population here. And let's say I'm going to pull out samples of size 10. Right. I've got all kinds of samples of size 10 that I can pull out of here. Right. And the question is, what types of results, what types of numbers are going to pop out from those particular samples? Right? So if we think about it, what could happen is I could pull out maybe this sample right here has all the high scores in it, which would give me a score right here. Right? Maybe this sample right here has all the low numbers in it, in which case I would get a sample average down there. Right? But most of these samples probably have some high scores and some low scores. So most of them are probably somewhere here in the middle, right? Where most of them will probably be right here in the middle as we start taking bigger numbers. So when we look at the sampling distribution, what it starts to look like is this normal curve, right? That's what the central limit theorem tells us. It tells us that as the sample size gets bigger, right? So as n gets larger, then the sampling distribution starts to look like that normal distribution. Right? Because this population, it could be anything, right? It could be uniform, it could be normal, it could be exponential. There's a ton of different ways we could describe that population, right? But I know that when I start taking samples, and in particular when I start taking really large samples, then those samples start to have this shape of the normal distribution. So what that tells me is I can then answer questions about samples. Right? So if we ever ask a question that looks like, what's the probability a sample will have a certain property? Right? For instance, in chapter 7, when we really started doing the z-score stuff, we were always looking at one person at a time. Right? What's the probability that Bobby has an average over 70 on his test? These types of questions might be, what's the probability the class will have an average over 70? Right? In other words, we're looking at a sample having a certain property. Okay? So if we're going to start asking questions about samples, we have to know what type of setting that we're in. Right? And if we have a big enough sample, right, where we said what n times p times 1 minus p has to be at least 10, if this holds true, then the samples have a normal shape where the average of the samples is going to be the exact same average as the population, so that'll still be mu. Right? And then, well, I guess p is what we started off with talking about proportions. Right? And then the standard deviation is just going to be the square root of p times 1 minus p over n. Okay? So that's really, in a nutshell, kind of what chapter 8 is talking about. It's talking about how we can start asking questions about samples instead of just individual people here and there. Okay? Now, if we're starting to talk about averages, then instead of using the proportion, we would use mu, and sigma over the square root of n would be the standard deviation for the averages there. So we have to read a problem. We're asking ourselves, are we talking about an individual or are we talking about a sample? If we're talking about samples, are we in the normal setting, right? So we can do this little check to see. Or if we already start off in a normal setting, then these samples can be any size, right? And then once we figure out, okay, I can use the normal distribution stuff thanks to the central limit theorem here, then what does that sampling distribution look like? It's going to be normal, and if we're using proportions, it'll have this mean and that standard deviation. If we're using averages, we'll have this mean and that standard deviation. Right? And that's what 8.1 and 8.2 are kind of going through. Right? All right, so does that help out a little bit for at least the concepts for chapter 8? Okay. And I think there's also, I think this is, I was starting to do videos at this point, right? So if you go back to Moodle, there should be some of those old lectures online too, to where if you're kind of bored late at night and you get really wanting something exciting to see, you should be able to go there and watch them. Yeah, I'm looking at it now, so they're on there as well for you to check out. I have. I have not. The test is going to be just like all our other tests, probably be about the same length. It'll be the same style. I'll go through there. I'll just find problems that I like in the book. I might change the numbers here and there just to make them a little bit different. But it's like we've talked about in class. As long as you understand the concepts and the ideas, the process is the same every single time, right? So if you have a sampling distribution problem, you use this process, right? If you have let's see, a confidence interval, you use, depending on if it's proportion or a mean, you use those types of concepts, right? So if you just understand the ideas that are associated here, the numbers I throw at you really shouldn't matter because you'll do the same work regardless of those numbers, right? So again, the big thing is, yeah, you want to go through and do some of the practice problems as well, but just make a little list, right? So for instance, in 8.1, write down the ideas in 8.1, right? And the formulas that go along with them, right? And then go to 8.2, write down the concepts and the formulas that go with those, right? And then kind of have that off to the side there and then go back and do some of these practice problems. And then you've got it sitting right there in front of you. So you know exactly what to do when you see those problems. Right? So that's at least one of the ways I would go about trying to start studying for this thing.